And now, although we have put the base of BGP in specifically iBGP in the last board itself, but try to understand why do we need BGP. The first thing first is if you want to make a particular this area, not area, the autonomous system, what is going to happen? Suppose you have AS100. Let's talk about that. Why do we need iBGP, right? It is going to be so natural to you, right? And suppose we have a route here which is 1.1.1.0/24, right? In this AS100, and we are on R1 right now. What we are going to do, we are running BGP between R1 and R3, which is AS300, and this is going to be your eBGP. You can understand why, because you are running BGP between two different autonomous system numbers. Similarly, here also it is your eBGP, right? What exactly your end goal is that you want to see this route 1.1.1.0 via BGP into AS200 1.1.1.0/24. Then the problem is that you do not have direct connectivity between AS100 and AS300. There is no direct connectivity, right? And if that is the case, then how you are going to get this route, right? How somebody who is sitting here can reach to somebody which is part of your 1.1.1.0 network in AS100. And that is interesting. So you find another AS number, which is AS300, which can take this traffic too, right? And that is why you are making an eBGP. So it means that this guy is right here. In R3 BGP routing table, you are going to see that B means BGP 1.1.1.0/24 can be learned via R1. And here is the path attribute. The path attribute is going to be only AS100. It is as simple as that. Here also. But the problem is how you are going to get this route into R4 routing table. There are multiple options. The first option is going to be, let's redistribute this route into the OSPF. Maybe your OSPF is running here, but you do not want to do that. And for that reasons, what are the reasons? If you and suppose if you are getting all the full routing table, if there is one or two route, that is fine. If you are getting the entire routing table, then you are going to choke your OSPF, right? The database. You are just generating type 5 LSAs in lakhs, which you do not want to do that. And that is why you must need a protocol which is of BGP caliber, which can take these 5 lakh routes from one place to other, which is not definitely your OSPF for sure. So what you do here, guys, you run BGP between R3 and R4, but you also know that if you run BGP on a same autonomous system number between routers of the same autonomous system number, it is not the external BGP. We know the name is going to be IGP, but now let's try to understand why do we need it. If you want to send this route, of course, you cannot redistribute into the IGPs because IGP cannot handle these many routes. And believe me, there are many people in network industry who have done this mistake. Previously, their OSPF network was running pretty fine, right? And then they run BGP and they redistribute these BGP routes in because they know redistribution. Everybody know that if we redistribute it into OSPF will routers will all get to know the BGP route, but they forget one thing. OSPF was never ever designed for such a huge network. We are talking about internet, guys. We are talking about autonomous systems. And there are so many autonomous systems, there are so many routes. And if you redistribute all of them into the OSPF is going to be choked. Many network engineers have done this mistake. Please do not do that in your environment. Do not redistribute all the BGP route into IGP. It is going to choke down your OSPF or the IGP, right? If you have that understanding, you are not going to do that, right? But what is the solution then? If you cannot redistribute everything of the BGP routes into iBGP or IGP, then it means that you need a same caliber protocol, which is your BGP, right? which can take these many routes, and that is why you're running iBGP between R3 and R4. And now the things are smoother. In what way? R3 is now advertising this route towards R4, and R4 is getting this route, that BGP route 11.11.11.0/24 is learnt again via R1 because BGP has the higher view of the network. It doesn't say it is learning via R3, right? And what is the AS number, guys? AS number is still going to be 100. Why? Because you are still in AS 300. It is as simple as that. If you had advertised this route from AS 300 to AS 700, suppose, then basically this route, when it comes here, then the path is going to be 100 and 300. But now the route is inside this autonomous system number only. It means that the route is still with R4. You are not going to append any AS number in this route, and this is very, very clear because you are still in the same AS. If you advertise it to the another AS, then definitely you are going to append your AS number. It means that when you do external BGP and when you send route to any external AS, you have to append your own AS path. But if you are inside the same AS number, you are not going to do that, and this is the difference, right? And this difference is causing a lot of problems because you try to understand between AS number, we have this beautiful attribute which is the AS path, and on the basis of this AS path we were actually preventing the BGP loops, right? You have seen that AS path was the loop avoidance mechanism in BGP, specifically in eBGP. But now we are not including this AS path inside the iBGP, and there might be the loops. If you didn't get my last statement, do not worry about it. We are going to spend time on it. But for now, just try to understand there is a need of a protocol which can take all of these routes from the BGP, and the BGP only can do that, and that is why we are running iBGP here. So one of the function of iBGP, why we are using it, because it takes a route from one autonomous system and it can route them across, or it can send these route to another AS number, right? And this AS actually becomes your transit AS. Why transit? Because traffic is going through it. Suppose we have a host here which is 2.2.2.2. Now this 2.2.2.2 wants to talk to 1.1.10. Of course, R4 now can send this this route 1.1.1.0 towards R2, and R2 is going to install this route into its routing table, which was your aim, right? When you started whatever this activity was, that the BGP route 1.1.1.1.0/24 is reachable via R4, and what is going to be the AS path cost? That is going to be the 300, and then 100. It is as simple as that. Now suppose 2.2.2.2 wants to talk to 1.1.1.1. What is the IP packet it is going to create? The IP packet is going to be has the source address of 2.2.2.2. Destination is going to be 1.1.1. This is going to be your source. This is going to be your destination. This is going to be your IP packet. When it reaches here, R2 is going to check, okay, it contains the route. And to reach the 1.1.1.1, it is going to send it across our AS300. Which packet is flowing across AS300? The packet which is containing the source IP address of 2.2.2.2. This is your source. The destination is going to be 1.1.1.1. Just try to see this packet, guys. The source address or the destination address, neither of them belongs to this address, and there was the definition of the transit, whether it's a transit area or transit AS. If a packet is flowing through it which does not have a source or destination from this area range, then basically this packet is just traversing this one. So this is becoming the transit area. Sorry, a autonomous system. Then packet is reached to R3, it is going to forward like this. It is as simple as that. So basically, to connect to different autonomous systems, you need a transit AS. And if there is a transit AS, that you need to run iBGP there so that you can take the routes from this autonomous system number and send it to this autonomous system number. It is as simple as that, right? But do we need it if we have only one router in this? No, then basically you take this EGP and advertise it into here. But because this autonomous system number is huge, you have two routers, then you need to run iBGP between them. It is as simple as that. The first use case to run iBGP. Yes, Mr. Burak, do you have any question on this board?
Yes, Vishnu. As far as I understand, the transit AS is not a good thing for us because from the previous scenario, the other company's traffic can transit over AS,
Then
but it's not
and that's
it's
what
not a good
yeah,
thing for us.
and that's what I said. That we are just talking about why do we need iBGP, right? You are
Mhm,
absolutely correct, and that is what I'm saying. You have much more control through policies, right?
mhm,
That
mhm.
what should go inside you and what should go, what should not. You can deal with it
Yeah.
later, right? But yes, try to understand. What if this is a service provider network? This service provider want, then something should come to me and then go out. He wants to be transit. Then it is useful or not? iBGP. I understand. If it is your
Mhm.
enterprise, then you why do you want that two different AS talks to you, right? You never want that. And that
Over us,
yeah, and
yes.
that is where your policies come into picture, right?
I see. Maybe we should block in our enterprise. We should block the
You are
transit
right. You are right.
function.
You are right.
Uh-huh.
But
Okay.
but you can block it and then basically and utilize the entire routing table that I should select the entire routing table for going out. And we will be discussing it. But the whole sole intent of today's exercise, whatever we are doing here, whatever the traffic flow we are understanding, that we should understand that there is an iBGP and there is a reason for that iBGP. Okay.
I see. My small second question is,
Mhm.
we can get a full route from the internet, or we can get a default route from the internet, or let's say from the ISP. In this case, what is exactly a partial route? Could you summarize it again, please?
Not partial route. If I say partial, the meaning of partial is you are not taking the entire routing table. Suppose the entire routing table is of 5 lakh routes, right?
Full
Suppose
full
the
route.
full routing table, right?
Uh-huh.
You say that I cannot handle with them. I want partial. Now, what is the definition of partial, right? Do you want only this routing table or this much routing table or this much? Do you need 75%, right? This you define, right? How you are going to define? Generally, what I say in terms of partial is that suppose this is my AS and I am connecting to AT&T. This is the AT&T network, suppose, or Airtel network, right? AT&T or Airtel network can give you the entire routing table of 5 lakh routes. No problems. But if you are not interested in that, you can say, Mr. AT&T, I am really not interested in these 5 lakh routes. Just tell me, just give me the route of your subscribers. Whoever customers which are connecting to you, and being an AT&T, it's a huge service provider. Maybe 1000 customers are connected to it, which are really really important. Maybe Netflix is connected here, right? And or maybe YouTube is connecting here, and you are going over it, right, to get the services of YouTube. So you are saying that whatever the directly connected autonomous system you have, just send me the IP addresses or IP subnet of those. Maybe those are only 2000s. say, right? Then AT&T is going to send you those 2000 routes plus a default route. So this is basically the BGP partial routing table because it is not full. Did you get it, Mr. Burak?
Yes,
Perfect.
yes, I get it. Okay, thank you.
Perfect. So now let's move to the new board, which is going to be the last board. I will take another 5 minutes of yours, guys. What is going to happen if uh, you need iBGP inside your autonomous system? You know all that, right? But do you need iBGP in your normal routers also? It is definitely clear that basically if I want to send a particular route from here to here, then I will be running iBGP. But now what I've done is there is no iBGP running here, suppose. And still whatever the routes I am getting, maybe 1.1.1.1.10 from Airtel, it should be inside my AS300. And iBGP is not running between R3 and R4. Say, for an example, I want these route to be on R5 and R6. Why I would like to have those route in my interior routers? I will let you know. Those are again going to be very, very interesting topics, right? So what I can do is I can form an iBGP neighborship from R3 to R5, from R3 to R6, and from R3 to R4. You must be thinking that Mr. Vishnu, we do not have direct connectivity between R3 and R4. Can we make iBGP neighborship? And that is where if I talk about eBGP, then it starts with some default. The default was the TTL value is not going to be more than 1 for the BGP route, and that is why it is ensuring that the neighbor is not going to be one off away from me. It is directly connected. And also it has the directly connected check also, that whether the neighbor is connected or not. It is as simple as that. But if I talk about iBGP, iBGP does not have any such restriction. It does not have restriction in terms of TTL. It does not have restriction in terms of connected check. It means that you can create a BGP neighborship between R3 and R4. You just need to have the route from here to here. Just need the reachability. And you have the reachability, of course, via R5 and R6. So you can create this iBGP peering. It is as simple as that. So what you have done is you have created 3 iBGP peering from here to here, from here to here, and from here to here. And whatever the route you are learning, 1.1.1.0/24, you are advertising here. So it will be there in R5, 1.1.1.0 via R1, right? Here also you are going to have this route. Here also you are going to have this route, right? Simple. But you must be thinking that, and of course, again, if you have some route here, maybe 5.5.5.0, suppose here, you can have the similar neighborship from here to here and from here to here. And of course, you had the iBGP previously also. But you must be thinking that why this guy is creating so many iBGP neighborship, right? Do we need them at the first place? Why can't we have only neighborship like this? iBGP neighborship like from here to here, then from here to here, and from here to here. There is a specific reason behind it. Why can't we have that, right? And that is what we are going to learn in tomorrow's class. But from this board, I want to just explain you why behind iBGP, because we need to transfer some route from here to here. That is the first reason. And maybe inside a particular AS, if I want to deliver the BGP route, I need to make a iBGP with that, so that it can take that route towards the R6 also, right? But why can't we have only this kind of iBGP and not this, not from a one-to-one to everybody, right? And if I have a connection from me to everybody and everybody has connection to everybody, it means that we are connected in the full mesh manner. And believe me, iBGP pairing required full mesh. And if it is a full mesh, then there are so many pairings. Why do we have that? We are going to talk about it tomorrow morning at the same time. Okay. If you do not have any questions, guys, let's meet tomorrow. But I could see a question from Mr. Burak. Burak, please ask your question.
Okay, thank you, Ishu. I think that it is better for us if we can talk some kind of scenario. Let's say layer 3, let's say we have got two different data centers, and let's say we are trying to make a DCI connection between them, and we are trying to complete a scenario like layer 3 DCI connection via BGP.
Okay. Maybe we can take this scenario
Or
maybe in the design section. This is
of course, it's your choice, of course. By the way, if we compare the design of DCI between layer 3 DCI and layer 2 DCI connections for the data center operations, if we talk both of them, then we can compare what are the advantages or disadvantages for both of them. It will be better, I think.
yeah, we can talk about it maybe in the design section somewhere that
Yeah.
but
Uh-huh.
I would be more interested in giving the input from the layer 3 DCI perspective. And the reason is I'm not sure
Mm-hmm.
how many people are going to understand the layer 2 portion because that is what I haven't completed. The layer 2 is
Mm-hmm.
totally different things there because you are extending some of your VLANs from one DCI to other DCI. Maybe the right approach, the right
May
approach is going to be that if we understand maybe the ACI and the ACI multi-site connectivity, and then we take on this that how do you connect? Maybe through the ACI you want to connect, or through L2 you want to connect, or through L3 you want to connect. Maybe we can talk about it. Maybe somewhere. You are right. Yeah.
Okay, maybe in design section, as
Yeah.
you said, small portion, small part of this
Yeah. I
subject.
can include
Mhm.
this scenario. Okay.
Sure, thank you.
Okay, guys. See you tomorrow. Bye for now. Have a nice day ahead. See you.
Thank you.
Vishnu,
Bye bye.
Vishnu sir, Anandi.